We're going to look at solving radical equations algebraically in this lesson. And this is a review from pre-calculus 20, but it does help us look at how to find an unknown if a radical is involved. So here are the steps you would have looked at last year or in your last course. First thing you have to do is isolate the radical. Then you start solving using algebra to find the variable, which is usually x in our questions. We have to verify all solutions and reject any extraneous roots or any extraneous solutions. And this is not an option when we're doing radicals. And then we state the restrictions on the radical at the end. So we're going to look at 3 examples, and this should review of what we knew. So last year we would have seen a question like this. Solve the square root of x minus 3 and then minus 3 equals 0. Now the first step was isolate the radical. Now the radical is anything underneath the square root sign. In this case, the radical sign, so all that radicand is x minus 3. So we need to get that by itself first. So the first step would be to move this 3 over. So now what we have is x minus 3 equals a positive 3. Now we need to start solving for that unknown. The next step to get rid of the square root sign or the radical sign is we do the opposite. The opposite of square rooting is squaring. So we're going to square both sides, which means I'm left with a 9 here and an x minus 3. Simple solving now, I add 3, so we're going to say x might possibly be 12. So I'm saying might possibly because the last step that we always had to look, or one of the last steps, is to verify this solution that we just saw and check to see if it's extraneous or not. So to verify, we go back into this original question that was stated, and we put in the value of x that we just found out. So we're here going to say, okay, 12 minus 3 is the radicand, minus the 3. We want to see if this actually indeed does equal 0. So 12 minus 3 is 9, minus 3 is 0. We're basically getting 3 minus 3 is 0, which that is true. This solution does verify, so this is a valid answer. And the last thing we're supposed to do then is look for any restrictions on the radical itself. Now if I examine this here, my original question, the radical is actually x minus 3. There is a restriction since this is a square root. I'm not allowed to have a radicand that is less than 0. So my radicand, the x minus 3, has to be greater than or equal to 0. So we have to solve for this inequality. Well, we just add 3 to both sides, and we're saying, well, as long as x is greater than or equal to 3, my radicand would be greater than or equal to 0 in that case, and then all my solutions that are bigger than 3 may be valid solutions. So these are the 2 things I'm looking for at the end, a solution with a verification and telling me any restrictions on that radical. So let's jump into a very similar type question. We got the radicand again of x minus 3, but now we're adding 3 to it. And we're going to go through and we're going to solve this. So we need to isolate the radical first, which means subtracting 3 from both sides of this equation, which leaves me with x minus 3 equals negative 3. If we just kept going along, we're going to square both sides. Whoops, that negative's also squared in there. Let's go back. Here we are. I'm going to just fix this up. So we had a negative 3 here, and we were in the process of squaring both sides. So now I get a 9. Over here, the radicand is left, x minus 3. We add 3 to both sides to solve. I'm saying possibly my answer is 12 again. So when I go to verify this solution, we start with that original question, which was x minus 3 plus 3 equals 0. So we're going to put a 12 in here. Plus 3 equals 0. It's 9. Square root of 9 plus 3 is 0. If you look now, I'm saying 3 plus 3 definitely does not equal 0, which means up here, this is an extraneous solution, which means, you know, we did all of our algebra right. We've done everything we're supposed to do, but it doesn't verify. So this is an extraneous solution or an extraneous root. So this question basically has no answer. We have to look at our restrictions on the variable or on the radical again. This was my radical, which means I need to have x minus 3 greater than or equal to 0 in order to take the square root of it. Add both sides. I'm sorry, 3 to both sides. The restriction is x has to be greater than or equal to 3 if I was looking at that. Now, I want to point something out here because this is pretty straightforward. We could see it didn't verify. But I want to point something out that was right here in this before we started to square root. What we had was the root of x minus 3 has to equal negative 3. Now, if you examine this, it's basically saying I'm taking the square root of a number and I'm getting a negative 3. Right at this point, we should know that this is not possible. We can't take the square root of a number and get a negative answer. So there we could have already determined that this would have no solution. So now we're going to look at the last question, which is a little larger, a little bit more work involved. So we're going to examine this, go through, do some verifications, and that should be our review of solving radical equations. So looking at this again, I need to isolate my radical, which means the 2x plus 7 is a radicand. I need to move this x to get this radical by itself. And then over on this side, I have x minus 4. Next step again, get rid of that radical, so I'm going to square it. That basically gets me my radicand. But on this side, when I square it, you should identify that x minus 4 all squared is the same thing as x minus 4 multiplied by x minus 4. So you got to FOIL and simplify to get this answer. So foiling x minus 4 times x minus 4 would get us x squared minus 8x plus 16. And that's some work that you did a lot in grade 10. Now to start solving this, this moves into how we used to solve things in grade 11 with quadratics. We want to move everything to one side wherever the x squared is positive, which means I'm going to take these things over to the other side. So I'm going to take away 2x here, minus 7 there. This is going to leave me with 0. And I have x squared minus 10x, and now I have minus 9. So this is a little bit more involved than the last few examples we've done, because now I'm left with a quadratic. And this quadratic now has to be factored. There's no leading coefficient, so all I need to look for is I need to have two things that'll multiply to a negative 9, but add to a negative 10. So all the things that multiply to 9 are 1 or 9, and 3 and 3. If I need it to multiply to a negative 9, one has to be, or sorry, this is a positive 9 right here. Sorry, has to be a positive 9. One has to be negative, and the other one would have to be negative as well in order to get me to a positive 9. So if I made both of these, this is a 9, a negative 9, this would actually add up to the negative 10 in the middle. So my factors are x minus 1, x minus 9 equaling 0. Now, we got to set both factors equal to 0. So this gives me one solution that may be 1. This guy to 0 gives me one solution, maybe 9. So now we actually have to verify both solutions to see if they work in that original question. So my verification now is two parts, verifying two separate answers. Now the original question was 2x plus 7 minus x equals a negative 4. So the first one I'm going to verify is 1. So I'm going to put that in. 2 times 1 plus 7 minus 1. We want to see if that equals negative 4. So 2 times 1 is 2 plus 7, that's the root of 9, minus 1, negative 4. If I look, the square root of 9 is 3, minus 1, negative 4. Well, 2 does not equal negative 4. Therefore, this tells me up here, this cannot happen. This is an extraneous root. So that is not a solution. I go and do the same thing with a 9 in that situation. So I'm going to verify 9. 2 times 9 plus 7 minus 9, we want to see if that equals negative 4. While 2 times 9 is 18 plus 7, that's the root of 25. Minus 9, we want to see if that equals negative 4. That's 5 minus 9. And indeed, that does equal negative 4, which tells me this is a solution. So the only answer I have in this case is x equals negative 9. We have to go one more step and talk about the restrictions on the radical. Well, it only comes from the 2x plus 7. That's the only place anything should have some restrictions. So we want to say that radicand, since it's a square root, has to be greater than or equal to 0. So we start solving this inequality. That gets me negative 7. Divide by 2. X has to be always greater than or equal to negative 7 halves. So what we found out, my restriction is x is greater than or equal to negative 7 halves. My solution is only x equals 9, and x equals 1 was an extraneous root.